Okay, this is absolute value equations and inequalities. So as we look here, we're in your SpringBoard book. Okay, we're in lesson 4-1. I believe it's on page 50. So you check, it should be on page 50. 4-1, you'll see this little graphic here of some people's names on a number line. Now, today we're going to talk about what is absolute value and what it means, and then also how to solve absolute value equations. So, first of all, let's talk about what absolute value is. Okay, you're given a problem here. It says Miss Patel is preparing the school marching band for a homecoming show. She has the first row of band members stand in positions along a number line on the floor of the band room. The students' positions match the points on the number line as shown. So you see Derek there is at -7, Kia is at -5, Mara is -3, Israel is -2, Laura is on 0, Tanya is on 2, Antoine is on 3, Nick is on 5, and Sam is on 6. So number 1 says use the number line to write each student's distance from 0 next to their name. For example, Tanya is 2 units away from 0. She's on 2, so that makes her 2 units away from 0. But Israel, who's on -2, is also 2 units from 0. So go ahead and fill in the distances from 0 for each person. Okay, you should have gotten Derek is 7 units away from 0. Sorry, my 7. Kia is 5 units away from 0. Mara is 3 units away from 0. Tanya is 2 units away from 0. Sam is 6 units from 0. And Laura is 0 units. She's on 0, so she's no distance away. Israel is 2 units away. Antoine is 3 units away, and Nick is 5 units away. Notice that all of your answers here are positive values. That's one thing about absolute value. Absolute value, and we'll go down here to the definition. Absolute value is it's the number, absolute value of a number is the distance from 0. So whenever we measure absolute value, we're asking how far is it away from 0 on a number line. So using absolute value notation, this is absolute value notation here. So we write the number on the number line with these bars that are right here. Mara's distance is the absolute value of -3. She's on -3 on the number line, but her distance from 0 is +3. If you look at Antoine's distance here, he is on 3. So the absolute value of 3 is the distance from 0. Both of them, though on different spots on the number line, Mara at -3 and Antoine at +3, are both the same distance from 0. They're both +3. And that's important to know about absolute value, is it's always positive. Because absolute value is the measure of distance from 0, we never ever measure distance in negative numbers. You would never say, I ran -2 miles yesterday, or my friend lives -5 miles from here. Now, you would never say that because we never measure distance in negative numbers. So it's important to note that it is always positive. Okay, now we're going to go down to number 2. Write each person's distance from 0 using absolute value notation. So just like Mara and Antoine are above, you're going to do the same thing. So we have, I'll just use D for Derek. Since Derek, if we go up here, since Derek is on -7, okay, as we go down here, we're going to write the absolute value of -7. Okay, that's the distance from 0 at -7. And of course, I mean, he's 7 units away. So go ahead and write that for the rest of the names. Okay, well, there's your answers. These are all the ones you should have gotten for Derek, Kia, Mara, Tanya, Sam, Laura, Israel, Antoine, and Nick. It's all of their absolute values at whatever position they are on the number line. All of their distances would be in positive values. Okay? Now we're going to go down to number 3. The location of two students who are 5 units away from 0 are the solution to the absolute value equation x equals 5. Which two students represent the solution of the absolute value equals 5? Well, if we go up here to our answers, which ones are going to be equaling 5? Okay, well, I know that Kia is 5 away from 0, and she's at -5. And then Nick is also 5 units away from 0, and he's at the 5 position. So notice that there are two values. There are two numbers on the number line who are both 5 units away from 0, -5 and +5. So we can write this. Kia is 5 and Nick is 5. Even though they're at 2 different positions, they're both the same distance away. And that's going to be for everything. On a number line, there's always 2. Unless you're at 0, there is always 2 spots on a number line that are going to be equal distance from 0. One negative and one positive. Okay, let's go through and let's go to. Let's go to number 4. So we go to the next page here on number 4. You're going to see a word problem here, and it says you can create a graph on a number line to represent the solutions of an absolute value equation. Graph the solutions of x, the equation x, absolute value of x equals 5 on the number line below. Then use the graph to help you explain why it makes sense that the equation absolute value of x is 5 has 2 solutions. Go ahead and do that now. Okay. You should have written something to explain that both -5 and 5 are both 5 units away from 0. And the graph shows that the distance from here to here is the same distance from here to here. They're both the same. Okay. We're going to leave 5 through 9, and we're going to do that in class. At another date, I should say that. So we're going to go ahead and skip to problem number 11. So go ahead and skip to 11 now. Okay, so now let's look at solving absolute value equations. Because absolute value is the distance from 0, and there are always 2 numbers that have the same distance from 0, when you get a question like A here, absolute value equaling 10, you have to understand that the absolute value can also be -10 because they are both 10 units away from 0. So how we write that in solving is we actually just put equals on the other side and put the negative value on the other side. So now I have a -10 equals the absolute value of x, which also equals 10. So both -10 and 10 are the same distance away. Now x is already solved. X is already by itself, so this is real easy. X just equals, and I'm going to zoom in here because this makes it a little bit easier to write. X equals 10 and x equals negative 10. That's terrible. Sorry, guys. Terrible 10. Okay. Now, let's slide over and do B. Now, B is a little bit different because it's telling you that the absolute value of x equals negative 3. That means it's saying the distance from x is negative 3. If you remember what I talked about before, we have to understand that you cannot measure distance in negative numbers. So you cannot, there is nothing that is going to be negative 3 units away from x. Okay? Distance is not measured in negative numbers, so this is no solution. Okay? Can't have the negative number, can't have it equaling, can't have an absolute value equaling a negative number. Okay? So, now we're going to move over to do C. Same thing as we did in letter A. This is saying that the distance from x plus 2 is 7 units away. So remember that there is another value, negative 7, that is also 7 units away. So we have to include that in our answer. Now, just like we did with the other inequalities, we solve for x. First step is to subtract 2, and subtract 2 from all sides. The 2's in the middle will cancel. Negative 7 minus 2 is negative 9 equals x equals 7 minus 2 is 5. So you have a solution of x equals negative 9 and x equals 5. That's it. D, same thing. Because it's saying the absolute value of 2x minus 1 is 5 units from 0. There is another value that is also 5 units away, and that's negative 5. So we have to include that. You have to put that negative value on the other side. And then again, solve like we normally do. Add the 1, add the 1, add the 1. Negative 5 plus 1 is negative 4. And then equals 2x, which equals 5 plus 1 is 6. Divide by 2, divide by 2, divide by 2. So I have x equals negative 4 divided by 2 is negative 2. And x equals 6 divided by 2 is 3. Okay. So says here in the equation x minus 3 is equal to 7. The 7 indicates the distance between x and 3 is 7 units. So there are always 2 points that are 7 units from 3, and that's why you see here they do a positive 7 and then a negative 7. Okay. So let's go, and we're going to go on to try these in A. We're going to scroll down here, and actually we're going to go to the next page. We're going to go to the try these A. Okay, here we are in the try these A. I want you now to try A, B, C, and D. So I've placed the negative 1, and since it equals 1, I put the negative 1 on the other side. And just like we did before, So hopefully that's what you got. Now go ahead and do B, C, and D on your own. There's the answer to B. So hopefully if you didn't get those answers, pause the video, see my work. Hopefully that helps. There's the answer to letter C. Hopefully you got that answer. Follow my work if you didn't. Hopefully it helps. Now on to D. And there's your answer for letter D. Notice how I left the fraction form. I'm not graphing anything right now, so it's easier just to leave it in fractions. -4 over 3 is perfectly fine. And then 12 divided by 3 was 4. So those are my solutions. Okay. Let's zoom out here. And now we're going to do example B. Now example B presents us with a different problem here. Now we have a problem 6 times the absolute value of x plus 2 equals 18. In these type of problems, it is important, the very first thing that you need to do is get the absolute value by itself. We need this absolute value by itself. You cannot solve an absolute value until it is by itself. A very common mistake that people will want to make is they'll want to, move the 2 out of here. You can't do that. Okay, the absolute value must be by itself. So what we do, and it's written right here, but just to show you, when I have 6 times the absolute value of x plus 2 equals 18, we have to divide the 6 over first. You can't do anything with an absolute value. You cannot solve it until it is by itself. Once you do that, you then get this answer here, and you get x plus 2 equaling 3. Now the absolute value is by itself. Now you can do the -3 on the other side and solve. But not until the absolute value is by itself. Now, so to look at some problems, to do those type of problems, let's go to try B. Okay. As we see in number 1, there is a 3 right here. Okay, we got to get rid of this 3. You cannot do anything with this absolute value until that 3 is gone. Okay, so since it's being multiplied, I'm going to divide by 3 and then divide the other side by 3. These will cancel, so now I'm left with the absolute value of x minus 1 equals 4. And you can solve it from there. B, with B over here, the only thing, here's my absolute value, so I need to get rid of this 14. And this is a little bit easier because it's just being subtracted. So if I want to move this to the other side, okay, I just do the opposite, just like when I'm solving regular equations. I do need to add the 14. Remember, you cannot solve an absolute value until the absolute value is by itself. These will cancel, so now I'm left with the absolute value of x equals 20, and now I can do this piece. And you can finish it from there. I'm not going to finish these problems. I'm going to let you do that, and I'll check it. We can come back to class on Wednesday if you have me on a black day. Obviously, that's an e-learning day, so I'll see you on Friday. Otherwise, I'll see you on Thursday. So, letter C. So, letter C, we have, here's my absolute value. It's not by itself because I got this 5 next to it. To move the 5 to the other side, we do the opposite, which is subtract 5, subtract 5. These cancel. So I'm left with the absolute value of x plus 4 equals 3. And now you can do this piece. Okay? Some problems If we look at D, some problems have multiple things. Here's my absolute value. I got multiple things I need to get rid of. The exact same way that you get rid of them in regular equations, you always add or subtract things over first. So this -7's got to go first. Then we can worry about the 3. But the -7 has to go first. We've got to do it, move it over. So it's +7 plus 7 plus 7. This cancels. So now I have 3, absolute value of x plus 6 equaling 27. Then I got to divide by 3. So the absolute value of x plus 6 equals 9. And now that the absolute value is by itself, now I can do the piece here where I put the negative on the other side and solve. I'm going to let you guys finish that when you see me next. For those of you who have me on a black day, on Monday, I'll see this is you. When you finish this, you can show it to me so I see you've completed it. Otherwise, I'll see you on Tuesday. All right.